Thank you. Thank you. Can you hear me? Okay. So today, 1 second. I need to see how much time I have. Okay. So today I'm going to talk about object-oriented programming. And my name is Alexander. Alex. I come from a distant land. I have a picture to prove that. Yeah. And I'm really excited to be here because Barcos is Argentinian and he plays for my team. And this is actually a very important picture because this was his first goal this year and it's his last as well. No, just kidding. I think he scored twice, I think. So today's agenda, I'm going to talk about perspective. I think that's the most important part because even though I can explain you things, if you don't get it from the right perspective, it can be problematic. I'm going to present classes and objects. You guys probably already do it, but I'm going to go a bit deeper. And I'm going to be more practical in this talk. I want to talk how can we stop losing money with our code, right? Un montón de citas from this guy, Alan Kay. This guy invented OOP. So whenever I say OOP, object orientation or object-oriented programming, right? So let's start with perspective. Alan Kay said that perspective is worth 80 IQ points. At first, I didn't understand what that really meant, but when I understood, it all made sense. Let's consider that we have 6 units, right? So 6 horses, and we want to sell those horses. If we were in the ancient time, we would probably use Roman numerals to represent those horses, right? But it was really hard to do any multiplication using Roman numerals. Really, really, really hard. Nowadays, we just use the Arabic number, right? It's really easy. Even kids can do math, can do multiplication just fine. Reality didn't change at all. The 6 units are still there. But the way we approach it changed, right? Simply the perspective in which we approach the problem made it a lot easier to reason about. One example is Isaac Newton. He had to represent the world in such a way that he couldn't, so he invented calculus, right? So when we deal with object orientation, that's a way to approach our problems, right? Object-oriented programming, though, deals with the programmatic, the code to reach at that goal. But our object orientation came before small talk, right? I'm going to talk about that, but keep that in mind. OO is more about perspective than code itself. I'm going to show you this. This is pretty interesting. If you look at those 2 tabletops, you think those tables have different sizes, right? However, as I'm going to show you, they have the same size, right? Okay, this is interesting, but the most interesting part comes now. Not yet. Okay. Are they the same size or not? Like, your brain continues lying to you. I showed you the truth, right? Now you should follow my religion. So even though you saw how it works, your brain continues lying and deceiving you. So we need to be really careful with that. When we are presented with new ideas, we need to try to rationalize about that as much as possible and not let our feelings lead the way, right? This is pretty scary if you think about it. It was for me at least, right? So what's OOP? Right? For Alan Kay, the guy who invented, OOP is nothing more than changing messages, local retention, and local protection, and ocultación de estado. So, okay, let's take that as our north, and let's talk about classes and objects. I'm going to present to you the differences between the two in a more clear way, and then we're going to the practical part. So here we have two planets, right? Two planets. They're two objects, but they're from the same class, planet. Okay, this is pretty obvious. Like we have users, right? User class. Here we have what we could call a class, right? We don't have the object here. We just have the plan for the future, but it has no value at all for us right now. We cannot fly, right? So classes are just blueprints for objects, nothing more than that, right? Here is an example where we have objects but no classes. This is valuable though. Without those, this pilot couldn't fly. So it's the objects that really give us value for things, right? There is the point of view of the developer, in which usually sees classes because that's what's in front of our eyes most of the day. And so the developer just thinks, well, I have the persona class, and I'm going to send them, I'm going to call a method in another class, and it's going on, and that's our reasoning, basically, right, as developers. However, if you think about that, what about the objects? Where are them? So we have, as well, the object's point of view. When you click build and run or start your program, in runtime, if we could imagine how objects behave, they would probably say, hey, I am somebody, I'm an object, I don't know who you are, I don't know what you do, but please pay. I would send that message, right? Just like when we go to a bar, we don't know who the person there is, we just say, give me a beer. We expect that person to understand that message, right? We don't care how it's going to be as long as it's cold, freezing. And then what happens is that most developers don't have this point of view from the object, right? And then when they move to a language that don't have classes, that doesn't have classes, the first thing they ask is, where are my classes? Where are my classes? And then things like this happen. JavaScript is an object-oriented programming language, right? But it doesn't use classes, it uses prototypes, right? And what do you do when you're learning a language and you don't have classes? Obviously, you create a new one. And then you have CoffeeScript and etc. In my opinion, no, it's a personal opinion, parentheses, prototypes are superior to classes, but that's another talk, right? So, yeah, let's talk later. I need water. Oops. No spoilers. Okay, let it flow a bit more. Okay, Now it's going to start to get more practical. Enough with the theory. Let's talk about objects now. When Alan Key had the idea about object, he had this computer, and so we had the computer, this box, and you don't know what is inside when you look at it, but you know there's the storage, the CPU, the memory, right? And then he asked himself, what if the storage was a computer? What if the CPU was a computer? What if the memory was a computer by itself? So you would have one computer with lots of subcomputers, right? And then all the details would be hidden inside those subcomputers, like virtual machines that we have today, right? So we could end with lots of computers sending messages one to another. See, this has nothing to do with programming so far. And then you would have like this architecture where this is one computer with lots of subcomputers. Each one of these would be one object. So one big object, a computer, would have sub-objects, right? And then you'd send a message to another computer, not a sub-computer, but another computer here with lots of sub-objects. And so on. This one obviously has lots of subcomputers or sub-parts that are computers, but I am just hiding the details from you because it doesn't really matter to you, right? So, okay, so this is the basic idea. From here, we're going to start developing now a more practical talk. How can we stop losing money? That's the secret for the universe and everything. The first thing that we should do to stop losing money is use messages. Okay, so why is that? I mean, so let's consider for a moment that we have this piece of code, this small piece of code. When you look at it, you don't even know what's going on there. But one thing for sure is that it's not really sending messages in the term of the object orientation, right? It's just procedural code. If you need to add something there, you're going to probably have to press enter here sometimes and then put an if. And then another else if, and else is, and so on. Instead of this, obviously, this is pretty beginner stuff, right? I'm going to go to the more difficult stuff in a minute. You should do the simple stuff that most people already know, just use the messages. So here we have one object. Oh, okay, we are inside the order object, right? And we're going to calculate the total price. We have the taxes object, and we just send a message, total, right? And then we get the total price. We don't care how the taxes are calculated, really. When you look at this code, I just want to know how the prices are composed. So with this in mind, the first rule, the effects are, I cannot read Spanish or I'm going to lose focus. Shorter methods, more readability. You know what's going on, you just look and you know what's there. Testability, I don't know if it's a word, in testabilidad in Spanish. Better reutilization or reusability, and less money wasted, right? Because you have to reason less. You waste less time. Time is money, right? Okay, the second rule. Now it's going to start to get difficult. The second rule, really use messages. Okay? Okay. So Alan Kay said, the key to scalability, I'm translating this from Spanish to English. So The key to scalability is in how the messages go back and forth, right? The key to abstraction and compactness lies in a happy combination between design and mathematics. Okay, let's take a look at what that really means. Let's consider we have two objects, right? We have two objects, one here, and we have this interaction between them. If we could measure complexity just by how the objects communicate, we could say that complexity here is 1, in this case. Now I'm going to add one more object. I added one object, but the complexity went to 3. So from 1 to 3. See, the complexity grows a lot more, a lot faster than the size of the system. If we have 6 objects, we already have 15 here as complexity. So how can we fix that? Well, there is a law in physics called the construction law. It's the only law in physics, only known law in physics that guides design in nature. It's pretty interesting. There is one shape in nature that's the most effective way of conducting flow from one place to another. And this shape is the tree shape, right? And it's so obvious that everywhere, this shape is everywhere. It's in the snowflakes, it's in the lightnings, it's in the riverbanks, it's in the lungs, it's in the streets. This is the most efficient way to conduct flow, to have flow from one place to another. How could we take this law from physics and apply it to our architecture? Well, we have 6 objects and our complexity is 15. We could do something like this, right? This is an example. I added one object and the complexity just went way down, almost half. Here's a comparison before and after. Here is using this constructor law, and here's how it was before. So using this kind of architecture, if you consider this for a moment, isn't it like the computers we just talked about? Like here you have one computer which only talks to this other computer via one particular interface. Isn't everyone nowadays distributing their systems because it's easier to reason about instead of those monolithic apps? Well, that was actually invented in the 60s, this idea of object orientation. So the effects of using this kind of architecture is less complexibility, the code is simpler, less cognitive load, and less wasted money, right? Bonus tip, just to reinforce, isn't a module a kind of object as well in Ruby? I mean, not in the language itself, but in the idea of object orientation, isn't it? Well, that's for another talk. Okay. Number 3, don't let objects spy other objects, right? No NSA. Local retention protection and local protection. So Alanka says that si estás haciendo ajustes a un objeto a partir de su exterior, estás haciendo programación de estructura de datos simulados. Is that right? En lugar de OOP. Okay, so we do that, right? User.name equals something. So let me show you an example. This is real code from a project I was working, I don't know, 2 years ago. And people used to do this all the time, right? They have this chain of calls, right? There is a law called law of Demeter. that says that you should never do that. And this is a pretty old law. And why is that? I'm going to show you this, but don't do this, right? Just trust me. What happens is basically this. You have these objects, the first object or the item. It goes inside the next object and goes inside the next object to get the country from the address, right? Just look at this code again. So what if you have to change the country here? Or what if you have to change the address? Or what if you have to change the store? You're going to have to change all the chain. Everywhere you're doing this kind of chain. I worked in a project, this is a specific project from this code, where some changes that, you just estimate as, that it would take like 2 hours. It would take like a week because they violated this law of the meter a lot. So whenever you had to do some changes, you had to change lots of other things, right? So instead of doing this, do something like this. Create the methods that pass along the messages. So that if you change one of the objects, you don't have to change the entire system. It's isolated. Don't do something like this, right? Like you have the public APIs here, all beautiful, but then one object that depends on the other object. So if you have to change B, you're going to have to change A. Right? Don't do that. So the effects are flexible code, less needed changes, and less wasted money. Time is money. Hide information. Let's look at this code. Can you see the send here? It actually returns true. But we define this as private, so what's going on? The truth is that there is no private thing in computers, right? The NSA is the proof of that. The private here is for humans. So if the guy there codes this, and I see this code, I know that this is not being used anywhere. I can trust him that I can change it just fine. I got this a class like a month ago that had like 20 or so public methods, all attribute assessors. And then I need to change that. There was a refactoring that needed to be done, and I had to check one by one, and like 1 or 2 only were being used. I had to check like 20 methods everywhere using eck. So instead of doing something like this for something that you're not going to use outside, put it under private, right? With this, we're going to have less coupling, less interdependent code, less wasted money, yak shaving. So classes are just a way to communicate with our team and the computer, right? We shouldn't look at classes when we're architecturing our systems, right? We shouldn't do class-oriented programming. We should do object-oriented programming. Bonus pro tip 1. Now, how can we better write our classes? What versus how? So let's take a look again at this example. If I am the client and I ask you, how is the total price? What happens when I'm going to pay for an order? Oh, sorry, the text is wrong. Don't read this part, please. What happens if I'm going to pay? And then you can just say, well, you're going to calculate the taxes. Oh, no, it's correct. And you don't need to know how it's done, right? If you want to know how it's done, you just use ctags to jump into that class to see, okay, how it calculates the taxes. Now, if you instead just code like this, you're presented with the how. You don't know what's going on, but you can know how it's going on. So you can read all these blocks and say, okay, this is doing X, right? So always try to write code that shows what's going on instead of how. Never, ever, ever use ER suffixes in class names. Why is that? Well, if you have something like order manager, and I sit down to read your code, the first thing I'm going to think is, well, I have an object called order manager. So probably I have another object called order, right? Because I have the order and I have the manager. That's exactly what it implies. I have one object, the order manager, and I have the order. It actually implies to me, before reading the code, that there lacks encapsulation, right? So instead of using something like connection manager, just do connection, or like Rails did, connection pool. It's a noun, it's something more, it's way better than something that ends in ER, right? Write great code, and to finish, there is this quote from Picasso that I love: learn the rules like a pro so that you can break them like an artist. Gracias.